In the previous subtopic, we know that which is a subtopic or section 10.3.3. You can go 10.3.3. Okay. We know that what is the definition of linear differential equation. So linear DE or ODE. This is the three characteristic of linear DE. So first, it do not occur as product. So what do I mean with products is example x dx dt. So we know that the dependent variable x, when two of them multiply with each other, so it will not be linear, it will be non-linear. So the second characteristic is the dependent variable do not occur as power. But what I mean by powers is like this. Dx dt square. Alright. So x is again the dependent variable. When it is powered, so it will no longer be a linear differential equation. And again, it do not occur in non-linear equation. Okay, example sine x. So again, x is the dependent variable. So sine is the non-linear function. So when this occur, this the differential equation is not linear. Alright. So there's a little recap for you. Most general first order linear DE form is dx dt plus p t times x equal to rt. Okay. So p and r is arbitrary functions of independent variable t. Okay. Again, p and r is the arbitrary function, any functions of independent variable t. Alright. So this is the general first order linear DE form. So in order to solve this, we can simplify, or we can use a simpler form, simple equation first, which is we can make the right hand side of this equation equal to 0. So let's say we solve that kind of problem first. So we will have dx dt, simpler problem. So dx dt plus p tx, so equal to 0. So r, we will not consider r yet. So let's say this equation we multiply with gt. G is also a function of t, independent variable t. So what will happen is gt dx dt plus gt pt x equal to 0. So let's say this is equal to 1, okay? And then okay, wait. So we remember from section 9.6.11, if you go there, we can see that an equation can be exact if delta p delta y is equal to delta q delta x. So in this case, which is we use x and t instead of y and x, therefore we can also change it. Delta p delta t is equal to delta q delta x. So okay, now when we compare this okay, this equation, when we compare this equation with this component in the exact equation, okay, you can see that this component this component, okay, is equal to pt, okay, and then the another one is okay, sorry, let me rearrange this equation first. So let equation 1 let multiply 1 with dt. Okay, so let's say we make a differential equation in the form of differential. So what will happen is gt dx plus gt pt x dt equal to 0. So we will have that this is equal to p t, and this is equal to qt. Alright. So let this one is equal to 2. Okay, when we compare this equation in the green box with equation 2 right here, so we can write that down again. Delta p delta t is equal to delta q delta x. So we will get that delta g delta t equal to delta x. Okay, remember what is p and what is q. So p is g. P is g right here, and q is G P X, right? So we can simplify that. We see that delta G delta T is equal to GP. Okay. And we can, if you look at here, this equation is separable. What I mean by separable is we can separate it. Separable. So the delta T we can move it to the right hand side, so we can integrate it. And from here we can see that this is no longer partial derivative, but it is a ordinary derivative. Okay, and we can put the G from the right hand side to the left hand side, G, and we can put the dt from the left hand side to the right hand side. So we can integrate P. Okay, don't get confused with the small p and the big P. So this is small p, P T dt. Okay. So when we integrate this, the left hand side, we will get ln G. Ln G equal to this one. And then when we can change the form G. Okay, actually this is not an example, this is just for your knowledge, how I can get the formula from this concept, and that formula you can use it in the example. Okay, so we can get GT. So this is the formula that we want to find is exponential K T. What is K? K T is equal to KT is this one. Alright. So this is the formula that we can use. This one, Alright. Have we finished? Not yet. So now, since we have know what is G, so again I just want to before I forgot, G is the integrating factor. G is the integrating factor. Okay, when we put G inside the equation 1, okay, equation 1 right here, we have G right here. So when we put back inside equation 1, so we will have E K T dx dt plus P T E K T x equal to 0. Okay. And next, if you look at this form of equation, this equations form, it is like a product rule, differential product formula. So it's like d uv. So we will have u dv dx plus v du dx, right? So this is the formula. So what we will have is, we can know what is uv. So to make things short, so we will have the final answer for d dt. The uv is equal to e k t x equal to 0. So when we simplify it, we will get this answer. You can try it by yourself. It's simple. So we know that x is the normal equation, and this is the derivative, and we know that this is the equation, and this is the derivative. Okay. So since we know this, so we can simplify it. We can find x in terms of the answer of x in terms of t. So we integrate it, k t x is equal to c. So x is c e negative k t. So this is the answer. So just to recall, this is the integrating factor. Okay, what is integrating factor? So let's say the original equation, which is this equation, when we don't have g, when we don't put the integrating factor, what will happen is dx dt plus p dx. This will not, it can be a non-exact dE, right? But when we put gt dx dt plus gt p dx, this will be exact differential equation. Okay. So now since we have know the answer, but we still not able to, we still not answer the full equation yet, because the full equation, if you look at here, it include the r component. The one that we solved just now is this one, which is equal to 0. So we can include the r right now, since we have solved the equation which is equal to 0. So we can write it down. Maybe I make a line. Okay, dx dt plus p dx equal to rt. Okay, so just we just need to multiply with g. Multiply with gt. So what will happen is e kt, remember g is equal to e kt, dx dt plus e kt p t x equal to E K T R T. And again, since we know the short form, this one, so we just replace the one with this form to this form. Okay, so the answer can be simplified. D dx E K T x.